Alright, we're going to start section 5.6 notes for the fundamental theorem of algebra. And just because I know you guys love jokes so much, and considering the time of the year, I found a really good math joke for you. What do you get when you cross an algebra class with the prom? Are you ready for the answer? It's the quadratic formal. Ha ha. Enjoy. Okay, so let's go ahead and start our notes with a warm-up problem. Number 1, find all rational roots for 4x to the 5th minus 8x to the 4th minus 32x cubed equals 0. So the first thing you want to do when you're finding the roots is, again, you always look to factor. And if we see here between 4, 8, and 32, we can factor out a 4. And between the x's, we can pull out x cubed. So I'm left with then x squared minus 2x minus 8. Alright, now I can set my factors equal to 0 and solve. So I set 4x cubed equal to 0. I divide both sides by 4 and I get x cubed equals 0. Well, that's really x times x times x equals 0 3 times, right? So we actually just write it as x equals 0 with a multiplicity of 3. Now for the next one, or the other factor of x squared minus 2x minus 8, we set that equal to 0. You can either look to do the quadratic formula, but if you take a look, factors of negative 8 that add to negative 2, you will see that this factors as well. And it becomes x minus 4 times a quantity x plus 2. So then I set each one of these factors equal to 0, and I solve. So I get x equals positive 4 and x equals negative 2. So I ended up with how many zeros? Well, we have 1, 2 right here, and 3 zeros right here. X equals 0 with a multiplicity of 3 means that it occurs 3 times. So that's a good review problem for us. So that was a total of 5 zeros. Now for the next warm-up, number 2, we're going to start that one in class tomorrow. Okay, so the next part of our notes, it says to look at the graphs of y equals x squared minus 4, y equals x squared minus 2x plus 1, and y equals x squared plus 2x plus 2. And then we want to find the roots for each polynomial. So you see that they're all 3 quadratics because they're all x squares. So go ahead and graph each one, and not so much finding the roots, but look to see how many roots each quadratic has. Okay, so I went ahead and I graphed it, and hopefully your graphs look something like each of mine do. Okay, now I want to look at the zeros. So this graph right here has 2 zeros, crosses the x-axis 2 times. This one only has 1 0, and this one has no zeros. Alright, but they're all quadratics, and like we talked about before, that if we should be able to find all zeros. If we have a degree of 2, that means that there are 2 zeros out there. So in this case, we have 2 real zeros. This one we have 1 real zero, which means the other one must be what? The other zero must be imaginary. If it's not a real zero, it must be an imaginary zero. And the fact that for the third graph we have no real zeros means how many imaginary zeros must there be? If you said 2, you are correct. Now we want to take a look at the fundamental theorem of algebra. And it says every polynomial function of degree greater than or equal to 1 has at least 1 zero, and that zero may be complex. Complex just means it may involve an imaginary part. It also says every polynomial function has exactly n zeros, including multiplicities. So what that means is if you have a degree of 5, then you have so many real zeros and so many imaginary zeros, but that the total of real zeros, number of real zeros, plus the number of imaginary zeros equals the degree of your polynomial. So if I have a degree of 5, I end up with a total of 5 zeros. That includes real and imaginaries. Alright, so example 1 says to find all roots of x to the 5th minus x to the 4th minus 3x cubed plus 3x squared minus 4x plus 4. So we're looking for 5 roots. These are 5 reals and imaginaries total. And I wrote your steps out there before, but these are the same steps that we've been using in section 5.5 as well. Alright, so the first thing we want to do is we want to plug all of this into y1. And then we're going to evaluate it. And to know what we're going to evaluate for, we want to do our rational roots test, which we take our constant term over our leading coefficient. So the factors of 4 over 1 end up just being 1, 2, and 4. So plug all of this into y1 and evaluate it. Now 1 and negative 1 are the easiest ones to check, so go ahead and do those now. Alright, by evaluating for 1, you'll see that we get 0. So what that means is x equals 1. And that's our first answer. Then let's go ahead and do synthetic division and break down that long polynomial. So we have 1, negative 3, positive 3, negative 4, positive 4. And don't forget to drop your mama. Now we already know that we should get a 0 at the end. So that's just what we're double checking here. And yep, there we go. So now this gives me x to the 4th. This is an x cubed, I don't need to write that. Minus 3x squared. I don't need to write this one, it's my 3x. Minus 4. Now you can go ahead and actually evaluate this one as well. Plug this one into y2 and evaluate it for the same rational roots. I went ahead and I evaluated this function for 2. I wanted to test that to see if it was a 0. And yeah, I got 0 from that, which means x equals 2 is another answer. Alright, so now I'm going to do synthetic division with this polynomial, and hopefully I can break it down into something I can solve it from there. I'm going to go ahead and write this over here on the right hand side of my screen. Remember, we're using 2 as our divisor, and of course we need to fill in zeros for our cubic term and our linear term. So make sure you have a total of 5 values. Okay, drop your mama. 1 times 2 is 2. Add them. Multiply. Add. Okay, so I get 0. This gives me x cubed plus 2x squared plus x plus 2 equals 0. Well, the coefficients 1, 2, 1, 2, I mean, I think I could probably do factor by grouping here. So I'm going to put parentheses around the first 2 and the last 2 terms. From this quantity I can pull out an x squared, and I'm left with x plus 2. From the next quantity there's nothing I can pull out except for a 1. So I'm still left with x plus 2. Now I see that I can pull out an x plus 2, and I end up with x squared plus 1 equals 0. Now set each of these factors equal to 0 and solve. Alright, the first one's just a linear factor. I get x equals negative 2. Go ahead and circle that one. That's another 0. And for the next factor, x squared plus 1, I'm going to go ahead and move the 1 over to the other side. So now I have x squared equals negative 1. Oh, I got to take the square root of both sides. And we end up with I. If you remember, the square root of negative 1 is I. And our conjugate root said that if I is a 0, then so is negative I. And I think we have now found all 5. We have 2, let me go back and change my pen color first. We have 2 zeros here, another 0 here, that's 3. This is my 4th 0, and 5. I have found all 5 zeros. Alright, so that last example was kind of fast. Let's go ahead and try another one. It says find all roots of x to the fourth plus 2x cubed equals 13x squared minus 10x. Well, when you're finding the zeros, you need to make sure your polynomial is set equal to 0. So I'm going to subtract the 13, bring it to the left-hand side, and then I want to add the 10. And as I'm doing this, I'm going to put it in standard form. So this really gives me the function x to the fourth plus 2x cubed minus 13x squared plus 10x equals 0. You always want to, again, try to break it down. And I notice that each of these terms have an x in them. So I'm going to go ahead and pull out the x. That gives me x cubed plus 2x squared minus 13x plus 10. Alright, so I actually already know 1, 0 because I set this one equal to 0 and then this long factor equal to 0. Well, when I set my first factor to equal to 0, it tells me x is 0. So I have indeed found one of 4 zeros. So now I'm going to be finding the zeros for this one. X cubed plus 2x squared minus 13x plus 10. Okay, now I have a smaller one. I am looking for 3 more zeros. Start with your rational zeros list. So I have 10 over 1, or just 10. Factors could be 1, 2, 5, and 10. Go ahead and do synthetic division until you find your first zero. Sorry, not synthetic division. Evaluate in your calculator. Well, when I evaluate that function, and for y1, whoops, sorry about that, I end up, and I'm plugging in 1. I'm evaluating it for 1. That ends up being a 0, which tells me x equals 1 is a 0. I'm going to use that 1 as a 0, do synthetic division, and break down this cubic function into a quadratic. And then I can either look to factor it, or quadratic formula works every time. So let's drop our mama and check that we do indeed get 0. And yes, so now I have something that looks like, and I'm just going to write it over here at the top, x squared plus 3x minus 10 equals 0. And I do believe that this one factors. There should be factors of 10, 5 and 2, that if I multiply them together I get negative 10. Positive 5 and negative 2 works. And if I add my factors I should get positive 3. So I think that works. This one I don't have to do quadratic formula. Alright, so I went ahead and I factored it. I now want to set each of these factors equal to 0. Whoops, scratch that. X plus 5 equals 0. X minus 2 equals 0. So this gives me x is negative 5. X is positive 2. And I think we have now found, let me double check, all 4 zeros. Let's see, we have 1 and 2 right over here, 3 right here, 4 right here. So at the very end, I'm going to go ahead and write x equals 0, 1, 2, and negative 5. That was much faster than the last problem. Alright, now let's go on to example 3. We are going to start this together, but you are going to finish this. It says a silo is in the shape of a cylinder with a cone-shaped top. The cylinder is 20 feet tall. The height of the cone is 1.5 times the radius. The volume of the silo is 828 pi cubic feet. We want to find the radius of the silo. So there's a lot of information going on here. First thing you need to do, draw a picture. So I have my cylinder-shaped silo, and it has a cone on top. Alright, so that's what it looks like. It says the cylinder is 20 feet tall. Well, that is the height right here. And then it says the height of the cone is 1.5 times the radius. Well, look at the shape of your base of the cone. It's a circle. So the radius is right there. The height of my cone is 1.5 times r. I don't know what the radius is, that's what I'm trying to find. We know that the total volume of the silo is 828 pi cubic feet. And we want to find the radius of the silo. We're going to do this by using the volume formula. So I have the volume of the cylinder, plus the volume of the cone. And together those should equal 828 pi. Alright, so we need some background knowledge. The volume of the cylinder. The formula is the area of the base times the height. And the base shape of your cylinder is a circle, so that's pi r squared times the height. That's for the volume of cylinder. For the volume of a cone, it is very similar, but it's going to be 1/3 times the area of the base times the height. So look at the area or the shape of our base for the cone, and that's a circle as well. So we're going to do 1/3 pi r squared times h. I've given you the formulas. We know what h is for the cylinder. It is 20. We have an expression that represents h for the cone. That is 1.5 r. So when I plug all these values into my equation, it should look something like this. Pi r squared times 20 plus 1/3 times pi r squared times 1.5 r. Alright, and of course that's equal to 828 pi. You need to solve this equation for r. Make sure you combine like terms and simplify. And then come see me if you have any questions. Good luck.